The graphs of quadratic equations. Now that we can solve any quadratic equation we're given, we want to spend a little bit of time talking about the graphs of the quadratics, important characteristics of them, finding important points of the graph, and being able to come up with a rough sketch. So the graph of a quadratic equation is called a parabola. It's in the shape of a U, either a U that opens up or a U that opens down. The most basic quadratic equation there is the equation y is equal to x squared, and it is a function, so the basic function f of x is equal to x squared, and this is the graph of it. It's a parabola that opens up, shape of a U that opens up. And some of the most important points is, first of all, the vertex, which is either going to be the lowest point on the graph if it opens up, or the highest point on the graph if it opens down, and it's also the point where the direction changes, where the graph changes from decreasing to increasing or increasing to decreasing. So the vertex, one of the most important points on the graph, along with the intercepts. The intercepts, some of the most important points on any graph. We've discussed intercepts before, so we know when we talk about the intercepts we're referring to the x-intercept and the y-intercept. And also an important characteristic of the graph is that it has symmetry. A parabola will have symmetry about a vertical line that passes through the vertex. Is called the axis of symmetry. It may not look like it on my sketch here, but if I were to make a fold along my screen or paper along this dotted line, these two halves of the graph should match up perfectly. It's not part of the graph, it's just a characteristic of the graph. It's called, once again, the axis of symmetry. So this is exactly what we're going to begin by finding. Given a quadratic equation in standard form, y is equal to ax squared plus bx plus c, we're going to find this vertex. Once we have the vertex, we can easily find the axis of symmetry and then the intercept. So first of all, the vertex. We know the vertex, once again, is nothing more than a point in ordered pair. So we need to find this x-coordinate, we need to find this y-coordinate. The way we find this x-coordinate is just using a little formula, negative b over 2a. So from the standard form, identify b, identify a, substitute them into that little formula, negative b over 2a, simplify, and that would be the x-coordinate. And like any equation, once you have x, just substitute it into the equation, and that will allow you to solve for y. Once we have the vertex, as we said, we can easily find a vertical line passing through that point, called the axis of symmetry, which any vertical line is always going to be in the form x equals something, and it's going to be equal to the x-coordinate of the vertex, negative b over 2a, whatever that simplifies to. Then, of course, the intercepts. We know we have the x-intercept. The x-intercept is always where? Y is equal to 0. So that's how we find the x-intercept. The y-intercept is always where? X is equal to 0. So that's how we find the y-intercepts. Now, given a parabola, we're going to look at three different graphs of parabolas here. In the first example, this parabola, this graph, obviously has two x-intercepts, but only one y-intercept. The second graph only touches the x-axis at one point. The vertex lies right on it, so there's only one x-intercept, and once again, only one y-intercept. And the third one, the graph, the parabola, never touches the x-axis, so there are not any x-intercepts, and touches the y-axis once again at one point, so one y-intercept. So from these three examples, which are the three possible parabolas, three possible outcomes for finding intercepts, you're always going to have exactly one y-intercept. All parabolas will have exactly one y-intercept, as we see here in these examples. And you can have either two x-intercepts, one x-intercept, or possibly no x-intercepts at all. So the possibilities for finding the x-intercepts, there could be two of them, there could be one, or possibly no x-intercepts. So we'll keep that in mind as we go through, look at example 1 in order to find the vertex, axis of symmetry, the intercepts, and ultimately make a rough sketch of the graph. So we recognize this as a quadratic equation in standard form. We can identify a is equal to 1, b is equal to -4, c is equal to -45. So begin by finding the vertex, more specifically the x-coordinate of the vertex. Using that little formula, negative b over 2a. So negative 4 over 2 times 1 simplifies to 4 over 2 or 2. So the x-coordinate of the vertex is simply 2. Substitute that into the equation in order to solve for y. Y is equal to 2 squared minus 4 times 2 minus 45 simplifies to negative 49. So we found the vertex. If we go ahead and plot it to negative 49, of course, way down here in the fourth quadrant. At this point, we certainly cannot sketch the parabola yet. For one thing, we don't know whether the parabola opens up or down, but the intercepts will certainly help us with that, because we know the vertex is either going to be the lowest point on the graph or the highest point on the graph. In the meantime, though, we can identify this axis of symmetry. A vertical line passing through the vertex is going to be simply x equals 2 in this case, the x-coordinate of the vertex. Now finding the intercepts. Well, we know there's always going to be exactly one y-intercept, so I prefer to begin by finding the y-intercept. The y-intercept is always where? X is equal to 0. So substitute x equals 0 into the equation. Y is equal to 0 squared minus 4 times 0 minus 45 simplifies to just negative 45. So if we plot the second point, the point 0, negative 45 lies above the vertex. So obviously now the vertex is not going to be the highest point on the graph. It has to be the lowest, telling us that this parabola has to open up. And if it opens up, that means we're certainly going to have two x-intercepts. So let's go ahead and find them. The x-intercept, where y is equal to 0. So y is equal to find the x-intercept. The x-intercept is where y is equal to 0, so 0 is equal to x squared minus 4x minus 45. Basically just solve this quadratic equation. Factors into x minus 9, x plus 5, which gives us two values, 9 and negative 5. So our two x-intercepts, the point negative 5, 0, and the point 9, 0. So if we plot these points, negative 5, 0, the point 9, 0, we can come up with a pretty rough sketch, accurate rough sketch of the parabola. Example 2, do the exact same thing. Quadratic equation in standard form. It is in standard form where a is equal to negative 1. B, though, is simply equal to 0. We don't have any x terms, so it's the same thing as 0x, which is 0. And c is equal to 4. So begin by finding the vertex. X, using the formula negative b over 2a, so negative 0 over 2 times negative 1. Well, 0 divided by anything is still 0, so the x-coordinate is 0. Substitute that in to find the y-coordinate. So y is equal to negative 0 squared plus 4, which simply equals 4. So we have the vertex, the point 0, 4. And since the x-coordinate is 0, we know that it lies on the y-axis. So therefore, the vertex is also going to be the y-intercept, the one and only y-intercept we know we're going to have. So at this point, if the parabola opens up, we're not going to have any x-intercepts. If it opens down, we know once again we're going to have two x-intercepts, which we'll find in a minute. In the meantime, we can find this axis of symmetry. Axis of symmetry is going to be the equation y equals 0. The intercepts, as we said, we already know the y-intercept, which is the vertex, the point 0, 4. So we want to determine any and all x-intercepts. X-intercept is where y is equal to 0, so 0 is equal to negative x squared plus 4. Solve for x, add x squared to both sides. Take the square root of both sides, not forgetting your plus or minus. X is equal to plus or minus 2. So we solve the quadratic equation. We have two real number solutions, which means we are going to have two x-intercepts. If they happen to be two imaginary complex solutions, we cannot plot imaginary numbers, so that would tell us that the parabola would open up, that there would not be any x-intercepts. However, plot them, -2, 0, +2, 0, and once again we can make a rough sketch of the parabola passing through those two. Now we're going to introduce a new form called the AHK form. It not only applies to quadratic equations, but it works for all functions. That's why it's so useful. But we're just going to be working with quadratic functions. So the AHK form quadratic equation is the equation y is equal to a times x minus h squared plus k. Where obviously instead of having the variables a, b, and c, we have the variables a, h, and k. So that's what we want to identify. A is still out in front. Find it right in front of the set of parentheses. H is always grouped together with x inside the set of parentheses, and notice the format x minus h. And k is just some constant at the end, plus or minus some number. So identify a, h, and k, which will easily then give you the vertex. The vertex will simply be at the point hk, where then you can find the axis of symmetry. And of course the intercepts are found the exact same way. Now what you could do with a quadratic equation in this form is simplify and get it into standard form. But later on, future classes, math classes you take, you're going to be using this form a lot, so we want to get used to it. Practice using this new form, AHK form. Like I said, it'll work for all functions, not just quadratic. So example 3, certainly a quadratic equation in AHK form. A is simply equal to 1. If you look in front of the set of parentheses, nothing's out there, so 1. H, inside the set of parentheses, x plus 5, so that makes h actually equal to a -5. The general form is x minus h. So if h was equal to a +5, you substitute in there, it would give us x minus 5 inside the set of parentheses. So therefore, to get plus 5, h must be a -5. X minus a -5 gives us x plus 5. In other words, the value for h will always be the opposite of whatever's written inside the set of parentheses. And of course, k will simply be +1. So pretty easy to find the vertex for an equation in this form, simply the point hk, so the point -5, 1, which also then basically gives us the axis of symmetry. The vertical line, x equals -5. Find the intercepts. Well, once again, we know there's going to be exactly one y-intercept. The y-intercept is where x is equal to 0, so y is equal to 0 minus 5 squared plus 1. Simplify. 5 squared root of 25 plus 1 gives us 26. And the x-intercepts. The x-intercept is, of course, where y is equal to 0, so 0 is equal to x plus 5 squared plus 1. Solve using the extracting the roots method. Get that power by itself. X plus 5 squared. Now get rid of it. Square root of both sides, not forgetting your plus or minus. So simplifying, the left-hand side, we see plus or minus square root of -1, where we know square root of -1 is I, an imaginary or complex number. So right away, we know x-intercepts cannot be imaginary complex numbers, so we are not going to have any in this problem. Which makes sense if we would have begun plotting the points that we already had, beginning with the vertex at point -5, 1. And since the y-intercept is going to be way up here at 0, 26, in other words, it's higher than the vertex. Therefore, the vertex must be the lowest point on the graph. In other words, it opens up, which means it would never touch or cross the x-axis. And example 4. Another quadratic function or equation in standard form. In this case, a is equal to -1, h is equal to +2, and k is simply equal to 0. So the vertex at the point hk, the point 2, 0, a point where now the y-coordinate is equal to 0, so we know this vertex lies on the x-axis, so it's also going to be the x-intercept, which we'll get back to here in a minute. In the meantime, the axis of symmetry is the vertical line x equals 2. The intercepts, the y-intercept is where x is equal to 0, so substitute that in. Y is equal to -0 minus 2 squared Watch your signs here. Negative 2 squared, of course, gives you a positive 4. But that negative out in front turns it back into a negative 4. And as we just said, the x-intercept is the vertex, the point 2, 0. So if we make a rough sketch of this, the vertex, once again, the point 2, 0. The y-intercept is down here at the point 0, negative 4. So we know this parabola opens down. Now you may notice something between both these forms of equations, the standard form and this new HK form. They both have the variable a, which tells us whether the parabola is going to open up or down. If we go back up to the standard form, example 1. Example 1, a was equal to 1 and the parabola opened up. Example 2, a was negative, where is it here? A is negative 1, or negative, and it opened down. Likewise, AHK form. Example 3, a was positive 1 and it opened up. Example 4, a is negative 1 and it opened down. So anytime a is positive or greater than 0, the parabola is going to open up. Anytime a is negative or less than 0, the parabola will open down.